Thank you for coming to my talk. It's after lunch, and if you had the turkey sandwich, I expect you to sleep. So if you didn't, you're in for a treat anyway. My name is Steve Husak, and I'm a distinguished engineer at CapitalOne. I've been at CapitalOne for 9 years, as of like 3 days ago, I think. And at CapitalOne, I am what we call an intent lead for Node.js and JavaScript. I'm also recently was moved into our open source program space as a distinguished engineer for the area, which essentially means I'm an individual contributor of a technical nature for the area and guide them through their technical stuff that has to do with open source. Previously, I have worked in the credit card space and the commercial banking space in various other roles as architect and leads there. I have a big passion around developer experience and engineering standards, which I think will come out in some of this talk. So I don't think I need this for this group. This was in for a European audience, but we are CapitalOne. We're mainly a credit card company. However, we do have a commercial banking division and a retail banking division, and we're mainly based in the US and with some presence in UK and Canada. This is a slide they make me put in that says we're open source first. So we're committed to open source usage and responsibility. We are sponsors in several different of the Linux foundations, including Finos, OpenJS, the CD Foundation, and Cloud Native Computing, and all these other ones. And we've been investing in years to build a culture and the governance required to be an open source first and in a highly regulated industry. And then another one of the slides they make me put in. This is our technology transformation. I don't know what to say about this one except that 2014 was like the year I joined, so I'm familiar with that point on. But essentially, we declared open source, and around that time in 2015, I think it was actually publicly declared. And we are all in on the cloud. We're all in on AWS and have been now for several years, as you can see from here. And now we're continuing that journey through the. There's no more transformation, I think. We're just continuing the journey of tech. So getting into why you might actually be here. I think as you've seen here and probably over previous years, the security landscape for everything has really changed in the past couple years. And specifically for Node.js and NPM, there's just been a proliferation of attacks on the ecosystem in many different ways. And what I'm going to do in this talk is kind of go through some of those attacks, what they are, and then some techniques that can be used to help mitigate the risk associated with this type of thing. So there are many different classes of attacks. Here I've outlined several. I think in the keynote today, they mentioned typo squatting as one of the big ones. However, there are other ones, and I think even more dangerous ones out there. And I'll get into a dangerous one that hit a lot of popular companies around 2020, I believe it was. But first and foremost, there is crypto jacking, which is code is inserted into a library, and it steals your CPU resources to do crypto mining. And there's an example here of a library in the Node.js ecosystem that was a victim of that, or a cause of that. Then the typical typo squatting, React model versus React modal is the prime example here. And then dependency confusion, and this is substitution attacks. This is the scoping attack and things that happen with the public registry and internal mirrors of registries. Then there's attacks based on data harvesting, ransomware, just general hijacking, somebody taking over somebody's account and publishing under their name. And then even unauthorized zone attacks. And this gets into somebody's trying to make a point or trying to turn their software into a money-making thing. So those are the many different attacks. The one I wanted to go into just a little more deeply, because I think it can affect an enterprise more so than anyone else. And this is a supply chain attack called substitution attack. And essentially what this attack is an attacker will go onto a registry, and I'm using NPM as the example here, and they'll first go on to GitHub, and they'll just do a search. And package.json, well-known vector of knowing where your dependencies are. They'll search all the packages on github.com and find any references that are unscoped. Then they'll match that against the NPM registry, the public registry, and if they don't find one, they have a vector of attack to someone. They may not know who right away, but what they do know is that somebody has a dependency somewhere that's not on the NPM registry, but is in a package.json. So what they do is they basically publish a version of it on the public registry, incrementing the version many ahead, and that's to help force the download of it. So then your developer inside your walls of your company will ask your local mirror for the latest version of that dependency. And the mirror will determine, hey, yes, I know this dependency. However, the version's updated on the public registry. So let me pull that one in instead of using the one I intend to use. And so the mirror pulls it in, caches it, and puts it on your developer's machine, overwriting the legitimate version. And then when the code executes or however it installs, the attack can take place. So in this case, the attacker has actually been able to infiltrate code onto your through the public registry onto your internal mirror of the public registry. And then all your developers are going to get that version until the version's changed yet again. I wanted to mention, this was based on a Medium article. There's tiny little attribution there. If you read the article, you'll find there are many companies you'll recognize who were affected by that attack. It was a theoretical attack, but still an attack. So how do we deal with this type of situation? I think at an enterprise level, there are many different ways to reduce your risk and remain well managed. And you're going to see Node.js and NPM mentioned throughout this talk. However, you can replace that with Python and PyPy, Java and Maven. This gets agnostic to a point, but I'm going to concentrate on Node because that's my area of expertise here at CapitalOne. So I'm going to go into being intentional on your usage of Node.js, using golden images, setting up for centers of excellence within your enterprise to help drive a culture of responsible use. I'll touch on SBOMs. I think that's the word of the day, so I kind of have to say it, so I'll just touch on it a little bit. And then a big thing now is pushing left the detection of this and keeping your developers educated on how to start to mitigate this even before code is checked in. And then how to adopt some best practices around security training and that kind of stuff. So one thing is being intentional in your Node.js version usage. So there are several life cycle stages of version acceptance. And they're here. The first one's upstream. Upstream is the people who are working on Node.js. They publish a new version and release it to the community. Then this is where we start going into the walls of your enterprise, the adoption, the support, and the deprecate. So adoption is when you bring in the software and make it available to your developers for use. And then support is just the ongoing maintenance of keeping that up to date, keeping and managing your deployment practices. And then finally, software gets to a point it gets deprecated. So you can see in the circles, we have a couple other steps in the process. And the first one is a maturity criteria. The maturity criteria, which I'll get to on the next slide, are kind of like the policy rules of how you're going to qualify a version is ready for acceptance within the walls of your company. And then that translates to the allow for use. So you're actually making it available to your developers. And then finally, when it hits the ELL or end of life stage, you're going to start to discontinue availability. And the nice thing about Node is it is very well publicized. You can, all the time, there's a thing on the bottom there. You can go and see their release schedule, and you know when new versions are coming, especially majors, and when they're going to be deprecated. So you can plan this well in advance. So I mentioned that maturity criteria. So only consider LTS versions. LTS stands for long-term support. So this is versions that are actually have a active security stance to them. They're going to respond to secure CVEs and things that are reported against them on a cadence as needed. And then they also have support, and that's long-term support. So only consider the active and the maintenance, and prefer active when possible, wherever possible. So that just means when Node comes out with a new version, the previous even version goes into a maintenance mode, which means it will still get updates. However, the updates are usually just security related or minor, or not even minor, patch version type of updates, bug fixes, that sort of thing. Sometimes Node will backport some features, but they have to be very safe. One thing for the maturity criteria is accepting security releases on the day of release. This is to avoid zero-day exploits. And in general, these should supersede all previous releases in a particular line. So for example, if 18. I don't know what number we're at today, but if 18.12.1 is a security release, anything less than that is automatically deprecated, should not be used. So in the 18 line. One thing that, from experience, is lagging minor releases by 2 weeks. And the reason for that is that allows for some discovery of some critical issues immediately after release. There's been very few cases with Node, but there's been a couple cases that I've seen people get hit by taking that minor release on day one. So just give it a little time. It's not a big deal. And the next two are like the ones that I really want to harp on, because moving to a major release is important to do it when LTS is declared, in my opinion. So we already have, Node already builds in lag into the release schedule, because if you're aware, Node 20 went LTS last week, I think October 24th. And however, it's been in development for, I don't know if I have it on the chart here, it's been in development for a while. And so it's already gone through a lot of that lag to become pretty stable for production use. So when it's declared LTS, it's basically ready for production. So it's a good idea to just take that when it comes. And then deprecate on the schedule. So when Node says something is deprecated or end of life, it means that they aren't going to backport any changes to it, no security fixes, nothing. So as you may be aware, Node 16 went end of life September 11th, and that was due to OpenSSL 1.1.1 going end of life. So you can imagine that there are still vulnerabilities in OpenSSL 1.1.1, and if you're using 16, you are potentially in a risky situation of unreported vulnerabilities, because they aren't going to get reported, most likely, or if they are, they're not going to get fixed. So one key thing here is you need to plan ahead for these end-of-life dates. Planning ahead is important, because you do need to test, you do need to be prepared, but coming in on September 12th and going, well, it's time to start thinking about moving to Node 18, is probably a little late, or could be too late. You might get lucky, but it could be too late. So recommendation here is start looking at it 90 days before end of life, the next version. It was a weird timing this year because of 18 and 20, because of the deprecation of 16 and then 18. We only had, I think we had 6 weeks of 18 by itself, which is weird for Node because we usually had 2 versions at one time. So, and now 20 is out. Now we're back to 2 versions. So some people probably waited until 20 came out to do their upgrades to avoid a double bump upgrade. So, oh, wrong button. So golden images are a concept of Docker containers or container images that are centrally owned and built and 100% vulnerability free at the time of building. And the reason to have these are, depending on your method of release, if you are releasing straight to a distribution point and your website's statically hosted, you don't have to worry about this. But if you're running something like Node.js as a server component and you're releasing to a Fargate or ECS or something like that in AWS, you want to have an image that is vulnerability free as well. So the idea of these are that they're, like I said, centrally hosted and a basis for your downstream container images. They're continuously updated for your base OS vulnerabilities. So if you're based on Ubuntu, you're going to be updating them for Ubuntu, and then you're going to layer Node on top of that. Or you're going to use the Node images and hope they're up to date as well. However, as an enterprise, we don't trust that, so we always put Node in ourselves. And updating the version based on the maturity criteria there. And then you can layer in your enterprise compliance tools and your scanning tools within that, or any application monitoring. But the idea is to give your developers a known good to start from and not trust them to build that known good. A way kind of out of this is to consider distro-less images. Then you don't have to worry so much about the base images being completely vulnerable all the time. Another concept that I found to be a good practice is to set up a center of excellence. And what this is it's a group that meets on a regular cadence. Their main goal is to help with the governance and recommendation of best practices and policies for the use of, in this case, Node.js and JavaScript within the enterprise. The COE should be made up of subject matter experts across your company. Ideally, you should have representatives from all your major platforms that are using that language or technology. And I'm not going to read off the main responsibilities because there's a lot. But an example of some of these responsibilities are approving the versions as they come in. These are also your go-to people for other tooling challenges you may have in your enterprise. So they're going to help with, how to deal best with NPM, how to deal best with running Node as a server-side component, and that kind of thing. They can help promote the safe and responsible usage of Node.js across your company. They can also be the stewards to your open source program of contributions outward from the company of being the experts in Node.js and being able to qualify and make sure that the contributions you are doing are good. So let's see. Yeah, and then our specific COEs, we own the NPM public registry and things like that as well. This is the required SBOM mentioned. So with Node.js and NPM and Yarn and the ecosystem in general, we kind of have had SBOMs, but in package.json format. So we have the package lock files or the Yarn lock files, which is actually a good SBOM. SBOMs in general, though, are based on a standard, and so you can start with package locks and then move up to the more standard SPDX format or other things and use Sift and other tools to generate them. But in my opinion, they should be tracked for every release and be a required artifact. And the reason for this is they provide a lineage of usage across your entire ecosystem during the build processes and allows for you to audit your releases afterwards. So if you start aggregating these in a database, you can then have visibility across your entire ecosystem where a specific package is being used. So if something bad happens to the Node.js ecosystem, like log4j, you could easily find it, hopefully, and be able to go straight to those systems that have it and then remediate it from there. So it can assist in that detection and find exactly where things are used. It's still not perfect, but it is coming along very nicely. Shifting focus now into what developers should be aware of. So one thing is developers should be continuously investing in the security landscape in general. So whether that's through training, just being aware that security changes basically daily, being aware of the top 10 OWASP and their common remediations is an important thing. Knowing that the top 10 changes is also important. But keeping your developers well-trained around security best practices is a good practice to do. Keeping dependencies update is also an important thing. And I'll get a little more into that in a second. But having your developers evaluate packages before use can actually help a lot too. So this starts to shift left, not through automation, but through introspection more than anything. And then you start looking at tools to actually start to automate these processes. So first, training your developers on lookup services before adding dependencies blindly into their projects. So doing just basic due diligence. The public NPM registry is a great example. You can get download counts. You can look at the code before you even bring it in. You can go to the GitHub and start to get an idea of what they are, and GitHub should be on this list as well. There are other services and products out there, like mentioned on the slides. You can even go look up CVE details beforehand. And then evaluate those packages all the way through release cadence, their release cadence, making sure they're releasing responsibly and at a clip that makes sense. So this is check to make sure things are well maintained and they aren't languishing or deprecated silently without marking them deprecated. There's a lot of packages out there currently in use that if you were doing a PR on, it's probably not going to get accepted anytime soon. And then, like I said, there are industry standard tools here to start scanning your dependencies and making this automated. And recommendation is to start blocking your releases based when standards that you set aren't being met or a CVE level is detected that exceeds thresholds for your risk tolerance. So actually starting to make developers a little more responsible for that. Using tools, this is to help reduce your developer toil, because that previous slide, it's a lot of work for a developer, and I'll tell you right now, that's the first thing that falls off the cliff is all those practices. So starting to make this automated is a very important thing. So you want to find the tools that work for your organization to scan for vulnerabilities, make sure your static code analysis is there. You want that in there. Even using a linter is a bare minimum. There are tools integrated into GitHub that can block PRs based on these results. And then there's other scanning tools that can help auto-remediate or discover issues even earlier. So a lot of these can suggest the remediation and even put a PR into your repo that's, hey, here's the fix for this. And then along with that is the dependency updates. So there's the vulnerability updates, but then dependency updates is just keeping things updated on a cadence that makes sense for your organization. So things like Dependabot, and I think there's a couple other ones, but these tools will do a PR into your repo with the latest versions based on policy that you can write and configure. I think the most important thing, though, for any of these tools to work most effectively is make sure you have reliable automated testing. And I'm highlighting reliable because if you have while true equals true as one of your tests, probably not a reliable test to detect if one of these is going to break you. So make sure you trust your testing. I think that's the important takeaway here, is any automation, you're going to make sure your tests are up to as equal quality as your code. For NPM in general, there are developer best practices here, and this is how you protect yourself against some of those attacks I mentioned up front. So using only trusted packages. These are ones typically have many, many downloads. They're well known in the industry, or although some of those have been taken over in the past, but you can usually find out. Looking at your foundations to see what packages they may be sponsoring is always a good thing. Lock versions in your lock files. I know a lot of people leave those open so that they automatically update on each install. Probably not the best thing. A lot of the tools that do those dependency updates actually, they don't require it, but they really heavily recommend you to lock your dependencies to specific versions. Even though you have a package lock file, lock it in your package.json too. I think one thing that's interesting is monitoring your network and process activity on Node.js processes. When you do an install, if you notice a network request go out that's not NPM registry, that package is likely doing something you probably aren't expecting. It may be going to download something from GitHub, but it's worth it to look into it to see if you can make sure it's not sending information off of your machine. I think the biggest thing here is don't publish private code on external GitHub if you can help it. That leads to that supply chain attack I was talking about. And to avoid that issue, apply scope to your packages, even your internal ones. So make sure all your packages have applied scope. And at the bottom, the OpenSSF has published an NPM best practices guide, which I highly recommend reading. It's not only for publishers, it's also for consumers, and it does have a lot of these details in it, plus a lot more guidance, including publishing on the public registry. So I think the basics are setting up two-factor. Actually, I don't even know if it's, I don't even know if you can't do that now. I think you have to do it now. Create and own your own organization on the registry. And if you notice your name's been taken, there are ways to get it back from NPM. You just contact them through support. And then obviously use scope packages if possible. That will protect you the best. And especially if you own that scope then through the organization on the public registry. So in summary, everything's changing all the time. The advice here was point in time. So you need to adjust and continuously reevaluate how you're going to, remain well managed. Keeping your developers up to date is a great way. Having a center of excellence that their job is to kind of keep their eye on things and keep developers aware is a great tool as well. Dashboarding and monitoring is another great way. I know that's an expensive way, but once it's implemented, it's a great way to get a holistic view across your entire enterprise on usage. And then following just the recommendations by NPM, the OpenSSF, Finos, and others on just best practices in the open source community is a way to remain safe. So that's it. There's another one of those required slides, and then I'm open for a few questions, like 3 minutes worth. Yeah?
Steve, could you talk about some tooling that exists to make a lot of the developer responsibilities you called out possible? Like,
what do you mean?
It's a lot of work. Like whenever you say you're looking to use a new package into your application to make something easier for yourself.
Yeah.
You gotta run through all these checks. What sorts of tooling?
So if you look, I don't know if you're a visual code user. Yes. There's a lot in the marketplace now for actually generating scores and having them as you're typing. So Socket.dev is a good company that has a lot of experience in NPM ecosystem, essentially. And they have a plugin into the IDE, and it will show their scores and a link out to their site, which will give you very detailed information on the dependency and give you an idea of what you're bringing in right at typing time. There's also other tools that you can install in your GitHub organizations to do that at PR time. Socket's another one. They have one. All the major vendors have a GitHub plugin at that point. And I'm pretty sure all the vendors also have the Visual Code or Visual Code plugin as well. So does that help? Sure. Yeah. Cool. Awesome. If you have any other questions, feel free to hit me up on any way you can get a hold of me. And great. Thank you.